Okay, so I'm going to start fresh. I just showed you a real overview of some of the interactive objects that are available. We're going to open actually the color selector, the code for the color selector. In other words, the object build was built with itself. We do use our own products to build the builder. So we're bringing up the color selector. This has all the member functions. Those of you that are used to intrinsics are used to callbacks. And what we have in the C++ world and the object-oriented world is our member functions. So we're going to go in here and do an examine. Hit a push button. Give the class name, the member name, whether or not to export that, button state name, setting value, window button state, and the official values, etc. Now this is a real primitive editor. Most builder editors are primitive, meaning that they're not very usable. And most developers want to go outside of that builder and use an Epic or a Emacs or beyond. Property sheet that allows you to configure an editor of your choice. This one is using Epic, so I hit the edit button. It executes Epic and comes that callback right in there. So now you have a real editor that you can, feel comfortable with and use to do the member function. In addition, it keeps the member function in a separate file instead of embedding that in your UV code or giving you templates, so you don't have to override it when you're changing your interface. It stays there. You can actually go outside of the builder and edit it with an editor, save it, and it will come into the builder correctly. So by keeping it in a separate file and keeping it modular like this gives you a lot of flexibility. Those that want to create new tools, they actually hit the create button here. Let's say we wanted to make this color selector an actual tool and save all the member function capability. You could actually hit the create button, name it, and it would be added to the custom part of the menu with all the colors, all the values, the member functions in there as a custom tool. Now, another interesting thing is that all these tools here are installable or uninstallable. You can actually remove them and install your own tools that are through your particular corporate style guidelines. So if you have corporate style guidelines, this allows you to enforce that. Okay, well, we actually will have a Q&A session at the end of this, but to answer that question, this right now is being ported to all major workstation platforms. We also are working on a Windows port, so we'll have portability to Onyx, Windows NT, Windows 3.1 on platforms as that. The X market is changing. So again, that's another reason why developing intrinsics may not be a smart decision today, because Windows NT and some other Windows environments are going to be coming.
May I have your attention, please? Now, we have a winner of the Apple PowerBook 140 from the Apple Boot 717. The winner of the PowerBook is Eric Lindbergh of Technicron. That's Eric Lindbergh of Technicron.
C++.
Congratulations.
2.0 C front compatible. So any AT&T 2.0 C front or greater will work. It will also generate an interface file. You can also execute. From the edit, you can do undo, redo, cut, copy, paste, all the standard things as far as showing glue and hiding glue. Composition. Now in the intrinsic world, these are called manager widgets. In the object views world, we have composition interactors. And you have things like HBox, VBox, pane window, deck trays, etc. You have ways to align and multiple view. Now this is a very powerful feature that's not really in other builders. It allows you to get multiple views of the same exact application, and basically if you're editing the member functions, you save it, it'll save those member functions. So this is the same view, or a different view of the exact same environment that you're building. actually starting up another object build. You can have multiple object builds. If you want to have 3 or 4, then you can be working on different parts of the interface simultaneously or have different views. So we have a panner object here. You can pan around, and you can also magnify. So you can, if you want to do fine detail control, you can magnify this, you can enlarge it, and you can do the things that you need to do in the different view. And they are tied together. So that's a very rapid overview of the builder. This currently handles interactors, and we will be moving to glyph support once glyphs stabilize from Stanford. And the interesting thing about glyphs is those will actually give you up to 100 times better memory consumption than intrinsics will. So some of the benchmarks we've done, it's a very, very lightweight object that can really decrease your memory consumption and increase your performance. And we will be providing a way to actually convert all your interactive code in the builder and write it out as glyph code in the future. Okay, so that's the open look, and another important feature here about open look and motif. Let's say you build in motif for several days and you want to actually look at it in open look. You can actually start the builder up in open look mode, read in your interface, and it will be in open look. So you can switch back and forth between motif and open look at any time within the builder and with your binary. Now we're going to look at a class browser. We also have a full class browser that looks at your local development directory that you're developing in, gives you your classes, and also gives you capabilities to search all of the classes. Right now we're searching all of the classes. Basically, if you look at all these classes, we have over 150 classes that you can use in object views. If you look here, you basically have the parents, and if you have children, you have children. We're also, for this release, implementing a full class tree that will have icons and allow you to see the complete tree. Now, if you want to search other directories, if you're using other class libraries, you can scan other files and directories. It looks for header files. You can clear the classes, and you can do forward, backwards, and line searches. Okay, so now we showed basically the builder, showed the capabilities with the overview of capabilities. Now we're going to show object draw. So, in the intrinsic world, usually you do the intrinsic work, then you use xlib or PEX, and you use a raw xlib canvas to do your other graphics. In the object views world, we have an object draw library, which is a high-level, object-oriented structure graphics library. I'm going to open a car here and just do a little demonstration. I click on this car, it's all one object. It's all connected. It's structurally represented as one thing. I can actually go in here and then ungroup it. And now all of a sudden I've allocated, I have many different objects here that are ungrouped. We have customers using this, for instance, that are in the automobile industry that actually are cataloging parts, have cars or vehicles that you can actually take apart. They're linking into object-oriented databases. Some are even linking into relational databases, but of course it's much easier to use an object-oriented database. And they can actually, we can actually strip this car down and zoom in, zoom out, pan around, and get higher levels of granularity. So you can actually get so I'm just controlling the panner object here. Okay, so that just shows you some of the capabilities with the object draw. We are working on having actual interactive data-driven objects, not in this release, but the following, so you could actually, within the builder, put a thermometer together and have full data-driven objects. You can do that today, but it's more from a programmatic perspective. You have to understand how to do that, outside of the builder. We also have xlib canvases and PEX canvases for those that need to do xlib and PEX within object views, and of course GKS or any other graphics, C